Let's look at how ratio and proportion can help us with some real-life problems. In geography, you will have seen that the scale of a map allows you to calculate the size, the height, and different dimensions of features shown on a map, as well as being able to work out distances between different points. The scale of the map is the ratio between the real-life dimensions and the dimensions on the map, the distances on the map. So, for example, the scale of 1 to 100,000 means that 1 centimetre on the map is equal to 100 centimetres in reality. This makes sense if you understand that 100,000 centimetres is equal to 1 kilometre. This means that 1 centimetre on the map is equal to 1 kilometre in the real world. So you can see that the scale hasn't been chosen randomly, it's been chosen to match reality and the sensible proportions of things that we can draw on a map. Many road maps will have a scale of 1 to 125,000. This is because usually when you're looking at a road map, you're trying to work out how to get from town to town. You're not too concerned about the detail of how to do that. You're not very concerned about what the buildings look like along the way, or how many houses there are, or how many trees there are. As we require more detail from our maps, we get different scales. So 1 to 50,000 would be useful for a driver driving within a town or a city. They'd need more roads and more detail and more landmarks. Or for walkers, again, who are walking, don't really care about the exact detail, just need to know how to get from A to B. Even finer detailed maps, 1 to 25,000, which is 1 centimetre for every 250 metres, are used by walkers in areas where they need a lot more detail to be able to see landmarks to know where they're going to and from. It's going to be useful to work out from the scale on the map how much a distance on the map means in real life. So here's an example. On a map scale 1 to 50,000, what length on the map will 35 centimetres be in centimetres, then in metres, then in kilometres? We're doing it this way to show that if you work through this process, you can work out what that distance means in any of those units. So first of all, in centimetres. Well, 35 centimetres on the map, it's 1 to 50,000, so it's 35 times 50,000, and that equals 1,750,000 centimetres. What is that in metres? Well, that's quite simple and straightforward, isn't it? There are 100 centimetres in a metre, so we just divide that number we've got before by 100 to get 17,500 metres. And then again, to work that into kilometres, that's also quite straightforward, isn't it? 1 kilometre equals 1,000 metres. So we're going to divide our 17,500 by 1,000 to get 17.5 kilometres. As you can see there, we could also have done that directly from the first answer. We could have done 1,750,000 divided by 100,000 because there are 100,000 centimetres in 1 kilometre. Either way gets the right answer. Let's look at another example. On a scale map of 1 to 100,000, the distance from Bristol to Bath is 18 centimetres. What's the actual distance in kilometres? So on a scale of 1 to 100,000, the real distance would be, we take the 18 centimetres and we multiply it by the 100,000, and that gives us 1,800,000 centimetres. Now we know that 1 kilometre is equal to 100,000 centimetres. So we can work out that distance in kilometres by doing 1,800,000 centimetres and dividing that by 100,000. And this gives us the result of 18 kilometres. What if we wanted to redraw our map so that it was on a scale of 1 to 125,000? How far would that 18 kilometres be then? From the information above, we know that the real distance is 1,800,000 centimetres. So on a map of scale 1 to 125,000, we would have to do the sum 1,800,000 divided by 125,000. Now we can cross off the thousands there and get 1,800 divided by 125, and that will give us an answer of 14.4 centimetres. So if we were to redraw our map on a different scale to 1 to 125,000, the distance from Bristol to Bath wouldn't be 18 centimetres, it would be 14.4 centimetres. So you can see that as we increase the scale, so we increase that second number in the unitary ratio, we decrease the distances that we're going to actually draw on our maps. Okay, let's look now at some slightly trickier examples involving areas on maps. So we're going to use a map of scale 1 to 1,000, so quite a detailed map. We want to know what is the area in centimetres squared on the map of a lake that actually has an area of 5,000 metres squared in real life. Let's draw this. It makes it a lot easier if you draw it. First of all, what happens on the ground in real world? There's our lake, which is going to draw it as a square, a rectangle actually, and that's 5,000 metres squared. Let's just say one side is 50 metres. If that's the case, then the other side must be 100 metres, because 50 times 100 is equal to 5,000. We could have chosen any values for the length and the width of that lake as long as the area was 5,000 metres squared. So let's now draw out how that same lake would look on the map. Well, we don't know what the area on the map is, but we know that one side is 50 metres and the scale is 1 to 1,000. So we do 50 divided by 1,000 is equal to 0.05 metres. That's 5 centimetres. Similarly, the other side is 100 divided by 1,000, which equals 0.1 metres, which would be 10 centimetres on the actual map. So this is going to give us an area for our lake on the map of 5 centimetres times 10 centimetres, which is 50 centimetres squared. Let's try another example, this time the other way around. We're going to work out how big something is in real life from how big it is on the map. So we've got a map scale of 1 centimetre to 5 kilometres. Note that we've given that in different units there, 1 centimetre to 5 kilometres. A farm is represented by a rectangle that's 1.5 centimetres by 4 centimetres on the map. So let's work out what the actual area of the farm is. Notice this is a really mixed up question. You've been given the ratio in two different types of units, centimetres and kilometres. You've been given the dimensions of the rectangle representing the farm, and then you're asked to work out the area. So you need to take note of what you've actually been asked here and the information you've been given. So let's draw it. Let's see what it looks like on the map first of all. So we're just going to draw a rectangle, any old rectangle, and one of the sides of the rectangle is 4 centimetres and the other side of the rectangle is 1.5 centimetres. So all we've done so far is taken information from the question and drawn it out into a diagram. I would always recommend that you do this. Now let's draw what it looks like on the ground. So we're going to draw our rectangle again. Draw it similar size and shape if you want to. And then we're going to work out what the lengths of the sides are. So we know the scale is 1 centimetre to 5 kilometres. Our longest side on the map is 4 centimetres. So the scale is 1 to 5. So 4 times 5 is equal to 20. But remember now, the scale is 1 centimetre to 5 kilometres. So the 4 is centimetres, the 5 is kilometres, so our answer is going to scale up to 20 kilometres. Similarly, we can do the same thing with the shorter side. 1.5 times 5 equals 7.5 kilometres. So this means that the area of our farm on the ground is 20 times 7.5. 20 times 7.5 is 150 square kilometres. I cannot emphasise enough how important it is to draw these diagrams. If you draw these diagrams, you are so much more likely to get these questions correct than if you try and do them without drawing them. Use all of the space that you have to draw the diagrams. make them as clear as possible, and then you're less likely to make silly mistakes as you go through the question. Also, make some notes on the question itself about the important parts of the question. Make a note of what the scale is, make a very clear note of the distances information that you've already been given, and also make sure that you're clear about what the question is asking you to find. In this case, it was the actual area of the farm. This may seem like a bit of time wasting to you, but in the long term, it will actually work out to your benefit. You're much more likely to get the answer correct.